I'm absolutely delighted and honored to be part of this very esteemed panel. And I'm very grateful to what you and your organization is doing for these patients. It's such a great a service and a real need in the community. And I'm also honored to have the opportunity to really lead the efforts here within the intramural program. And what I want to do is share with you um, where we stand at the current moment. So we designed a 3-phase study and within the intramural program. And what I'm going to do is share with you where we stand with the first phase, which is a cross-sectional study, a deep phenotyping of patients who have ME/CFS, but is a subgroup of ME/CSF who clearly had an infectious process that triggered it. The idea really was to try and understand the pathophysiology of the disease. So at the time when the COVID pandemic hit, this is where we were. We had close to 500 inquiries. We then drilled them down to 27 individuals that we brought to NIH with post-infectious ME/CFS and did very deep phenotyping. Of those, it turned out that really 17 had ME/CFS. The others had other underlying diseases that really did not fit the criteria, but it really took a lot of effort to really diagnose those other underlying diseases. We had brought in 25 healthy volunteers that also underwent very extensive testing. Turned out that about 4 of them had some other underlying diseases. So not everybody who says they're healthy really is healthy. We found all kinds of other diseases that these individuals had. So we, at this time, decided to, because the clinical center had shut down and we couldn't bring in any more patients. So we decided that we should just look at the data we have. And so we moved into a data analysis phase. We had done a very extensive testing on these individuals. So this is just a list of the things that were done. And as you can see, for each one of them, we had a principal investigator looking at each aspect. And then they had their own team of individuals who are further analyzing these things. So it was a massive effort of a huge number of investigators from multiple different institutes that are all come together in order to try and see what they can do to understand this disease further. So currently for our data analysis, what we did was we formed working groups. And so we have a clinical description working group, an immunology working group, a physiology working group, and I should have put in bioenergetics. There's a bioenergetics working group. And now we have a manuscript writing team because most of the analyses, not all, but pretty close to, we are finished doing the analysis now. So this is what the clinical description working group is working with. And so there are all kinds of parameters that they have. And so I'll show you at least some of the analyses. So the healthy volunteers and the ME/CFS groups are fairly well matched, as you can see here with age, as well as with body mass index. You can see that they're fairly well matched here. And then we did a number of different scales that we applied to them. These are all self-reported, but nonetheless, they are important pieces of parameters that we capture from each of these patients. And you can see that they have decreased physical abilities, and also they have their scores on mental functioning is also diminished in the patients with ME/CFS. And they do report more fatigue on these scales, and they report more sleep disturbances compared to the healthy volunteers. We also measured their hand strength, and what we found was that they do have the ability to give you maximal hand force, which is equivalent to those of healthy volunteers. So their ability to at least give maximal strength is very good. However, their time to fatigue was rather short. So they fatigue very quickly, while the healthy volunteers took longer in order to fatigue. We did a number of pain scales that we applied to the population, and what we found was then all of the pain scales, they performed quite differently compared to the healthy volunteers, and they had increased pain intensity, interference, they experienced more distress from the pain, and they also had some tender points that could be identified more so in the ME/CFS patients. We also did the skin biopsy on these patients and then measured the nerve fiber density, and that was done by the group at Hopkins, where we sent these skin biopsies, and they did not find any abnormality in the nerve fibers. We also did very extensive cognitive batteries, about like a 3-hour battery on each one of them. And we found that on a number of parameters, the patients with ME/CFS did poorly. So that included attention, verbal memory, language, visual spatial perception, and visual memory as well. We also did a number of scales to look at depression and anxiety. Here I'm only showing you 2 of them. And what we found was that the ME/CFS patients, for the most part, some had, they did fairly well. I mean, you can see these dashed lines represent where there's a cutoff for normal. So the number of individuals who were normal, there's some that had mild depression, and only 1 individual had moderate depression. Same thing for anxiety. Most of the ME/CFS patients actually did fairly well. We had some with mild and a few with moderate anxiety. Okay, so then we have a physiology working group. I'm not showing you any of the data, but these are the various types of measures that we have collected on each one of them. And so much of that has been analyzed, and there's a few things that we're still in the process of finalizing. And then we have the immunology working group, and we've done very extensive immunology on these patients. Again, I'm just going to share with you the kinds of things that we've done, but the most of the data has now been analyzed. I think the challenge is to try and come up with a cohesive story. Some of these things are a little bit hard to reconcile. Nonetheless, one of these assays is a SomaLogic assay. And so these are the summary of the different types of proteins that we detected in the spinal fluid and serum of patients with ME/CFS. And you can categorize them by their functions, as well as by whether they're intracellular or extracellular. And so we looked at about 1,300 proteins in these individuals. We also, not just the proteins, we also looked at the mRNA. So we sequenced the mRNA from the lymphocytes in the blood, and those have also been analyzed now. So we have the ability to now see if there is correlation between the RNA and the protein expression. We also looked at the gut microbiome, and although I'm not showing you the data, I think the data for the most part validates the kinds of studies that Dr. Lipkin has done in his group, which is actually very good, because one of the problems in the field has been reproducibility across cohorts. So we're delighted to see that in a different cohort, looking at different parameters and different ways of analyzing the data, we come up with the same conclusion. So I think that is actually very rewarding. So for whatever it's worth, we did the NK cell functional assay. This is a radioactive assay that we got done at Cincinnati Children's Hospital. And at least using that assay, we did not see any difference in the natural killer cell function in either of these groups. And lastly, we did a number of tests looking at bioenergetics, and I'll share with you some of that data. Okay. So here, shown here is that these patients undergo exercise, and you take them to the anaerobic threshold, and then you get to measure the amount of work rate and oxygen consumption. And in both of these parameters, patients with ME/CFS did much poorly compared to healthy controls, suggesting that there is metabolic inefficiency. We also looked at mitochondrial function, and again with exercise, and we found that following exercise there was decreased maximal respiration in patients with ME/CFS, and also there was decreased spare respiratory capacity also. So these mitochondrial functions are measured in lymphocytes using a instrument called Seahorse, so that measures the mitochondrial function in real time. So I'm going to stop here and acknowledge a large number of individuals who have contributed to this data and to the study of these patients. And most importantly, I want to acknowledge Brian Vollett, who is the lead investigator and really has done the lion's share of the work in organizing the entire study, and all the investigators putting the working groups together and keeping us all on track. So without his help, none of this would have been possible. And of course, I would really want to thank all the volunteers who participated in this study, because they're volunteering their body without really getting any immediate benefit from it. So that kind of an altruistic view is really very much appreciated. I'll stop here and take any questions.
Thanks, Avi. There's just some clarifying questions. So one, and I noticed this too, you said that the NK cell studies showed no differences, but I noticed that there are some individuals that were very high. And so do you think that there are subtypes? So some individuals may show NK cell dysfunction, but when you group them all together, you don't see that difference.
That's a fair question. The sample size is small, so unless there was a robust change in all the patients as a group, we wouldn't see it. But it's true that if you were to look at large sample sizes, you'll probably be able to tease out further subgroups within this population. Makes sense.
And there was a question about the mental fatigue symptoms. The y-axis was age. Is that correct? Or on your slide with the mental fatigue symptoms?
There's age. No, there's not age. That's just the T-score.
Oh, okay.
Yeah, right.
Okay, and let me see. Let's see if there's one more question here for you. So there's a question, Dr. Nath, about was there any indication of neuroinflammation in the CFS analysis?
So we do find some abnormalities. That's, I don't know if I call it inflammation per se, but yes, there are immune abnormalities that we did find in the CSF. And so we will be putting those together.
Right, and I know that you talked about the metabolic chamber work that was done. All of that data is currently still undergoing analysis. Is that correct?
Yeah. Yeah, it's most of it has been finished, so we're just putting it together right now.
Okay. So I think with that, we'll move on, Phil, and come back to some of the broader questions for all of the panelists during the general discussion. Thank you, Dr. Nath.
Oh, thank you.
Thank you both. Actually, I have the benefit of asking a question myself. So if you don't mind, Dr. Nath, we do have a couple more minutes. And as Vicky said, we'll get to the larger questions later. But this work is as far as I'm aware, the most comprehensive assessment that's ever been done of a cohort of patients with ME/CFS. And I wonder, having finished the work, is there anything in particular that you learned that was surprising to you, or that you would strongly recommend further work be done on? In other words, what jumped out, and if you had control of what happens in the future, what would you be looking at?
Okay, so I'll have to tell you, the most surprising thing is what I didn't share with you is when you analyze the immunology data, the immune dysfunction, there's a big difference between men and women. The pathways activated in men were very different than women. So I had mentioned that in a previous meeting, that biggest discovery has been that men are different than women. Yeah. So I think we have to be careful when we look at larger sample sizes and in other studies to look at gender differences. I think, sometimes that gets mixed. But I think that's very, and in such, ME/CFS is more common in women compared to men. A lot of immune disorders are more common in women compared to men. And so I think separating the two populations could be very insightful.
Interesting. Okay, well, thank you very much.